Hi everyone, it's Nathaniel. In today's EMT Quick Hits, we're going to talk about medication administration and some basic pharmacology for the EMT Basic. So I want to start by looking at these three medications. These are the three most common medications that you will draw up to give in some type of liquid dose, either through an IM, sub-Q, or intranasal injection, or even orally. So we really need to know how much of this we're going to draw up and how we're going to administer it. Now, we're not going to talk about the routes here. I'm not going to show you or teach you how to do an intramuscular injection. But what we're going to talk about is instead how much do you draw up and how do you figure out your dosing. There's just a little bit of math involved, but don't worry, it's not difficult at all. It's very, very simple. So, the question that we really are going to focus on today is, how do I know how much medication I'm going to draw up? That is the question, because as you see in these pictures, medications come in many different vials, they come in different concentrations, they come in different formulations. So, what do we do? Well, fortunately, the method is the same no matter what concentration that your medication comes in. But first, a few things that we need to note. First of all, mass does not equal volume. And what I mean by this is I hear students, especially in an EMT Basic class, saying, oh, I'm going to draw up 0.5 or 0.4 milligrams of Narcan. Okay, that's fine, but that doesn't mean milligrams does not equal milliliters. So if you tell me the dose is 0.4 milligrams, if we say we're going to give Narcan, and you tell me that your dose is 0.4 milliliters, no. Okay, that is not true. Mass does not equal volume. Doses are in mass. Doses are in mass. When we talk about what is our dose of a medication, what are we going to give? Now, the volume that we draw up, and you might even call it the dose that you give the patient, might be the volume, but it does not equal the same thing. So milligrams do not equal milliliters. That's this part up here. Very, very important. And when we're drawing a liquid medication up, we draw up in milliliters usually, or some type of liter-based volume, most commonly milliliters for most of our medications that we're going to give. A certain number of milliliters leads to a certain number of milligrams, but they do not go back and forth. Okay? You cannot just always rely on the fact that milliliters and milligrams convert. If your concentration is 1-to-1, then the numbers equal out, but mass does not equal volume. Dovetailing off of that is concentration matters. Okay? The concentration that is in our vial, or whatever we're drawing up from, matters, because without the concentration, we don't know what the volume that we're going to draw up is. So this here is a vial of Narcan. Okay? This is also Narcan. Their concentrations are different. If you look closely here, okay, this is Narcan at 0.4 milligrams per ml. This, on the other hand, is 2 milligrams per ml. So the concentration is different, and because of that, the volume that you draw up, the number of milliliters that you draw up to get to the same dose will be different. Okay, so how do we deal with mass? Well, let me give myself a little bit more space here. Mass does not equal volume. So when we look at our concentration, let's first look at this first vial of naloxone, this first one up here. Okay? Number 1. This is 0.4 milligrams in 1 ml. this is useful to us. This is what we use when we're drawing up meds, and we'll do a couple practice problems down below. This one here, number 2, is 2 milligrams per ml. So we say number 1, and we say number 2. Okay? It is 2 milligrams per 2 mLs, which, using some very basic fraction here, is 1 milligram per 1 ml. Now this means we have a concentration of 1, which is super useful because in this case, numerically, milligrams and milliliters will be the same thing. And we'll work through that problem here at the end. But a 1-to-1 concentration makes the math super easy. Something like this one, okay, over here, makes it just a hair more tricky, though it's really not bad at all. All right, so next, units matter. All right, and this is true for several things. First of all, in the metric system, you use different prefixes, right? You've probably heard kilograms. Okay. If you don't know this, a kilogram equals 1,000 grams. And the prefixes just change. This is our base unit for mass, it's grams, and the prefix indicates a power of 10. Okay? Indicates powers of 10. Right? That's what makes the metric system actually fairly easy to work with. So kilo means 1,000. Kilo means 1,000. And it doesn't matter what. Not 1,000. Okay. And this can be grams. This can be liters. You can have a kiloliter, right? You can have a megaliter. Most of the time when we're dealing with volume units, we're dealing with things like milliliters or liters. You don't normally see kiloliters, but it is technically correct to be able to do that. Most of the time in mass is where we see these different things. Megagrams, kilograms, micrograms, milligrams. Okay? So kg equals kilograms. Mg, little m. Okay? This one here is a capital K. Little m is milligram. Okay? Often abbreviated mcg is microgram. And if I put one up here at the top, big M technically would be megagram. Now, it's very common to see these two things kind of together, right? Capital M, little m. Technically, we use the capital M's for the big powers of 10 and the little m's, the little letters for the things below 1. So, but you often see these together. You need to use a little bit of a context, right? It wouldn't be correct if you had a vial that said, 0.4 megagrams in 1 ml. That would be a little bit difficult. So, context is important here, but our units matter. The other one that matters, let me give some space here, is when we're doing med math, this is when you're using the metric system, you need to use the metric system for everything unless you use some pretty interesting conversions there. So most of the time in medicine, we use kilograms. So weight is in metric in grams. Most of the time, we are going to be using, in our dosages, when you're looking at your protocols, you're going to see things like 10 milligrams per kilogram. So, if you are given your patient weight in pounds, which here in the United States, most of us know our weight in pounds, you're going to need to convert. So, the one that you need to know is that 1 kilogram equals 2.2 pounds. Now, a quick and dirty way that we do it in the field sometimes is we very quickly convert, and we can say, 1 kilogram approximately 2 pounds. In a lot of cases, that conversion will not result in an overdose on a patient, but to be absolutely correct, this is the one that you're going to use. Let's not erase that, let's highlight it. This is what you need to use here, 2.2 pounds. All right, so with that information under our belt, how do we know how much to use? Well, it's very simple. The formula that you use is the dose you want over the amount in your bottle times the volume of your bottle or vial. And this gives you the volume that you're going to draw up. Okay? So the way that you'll see me write this is want over have times volume equals, and we'll just use a colloquialism, we'll say dose. Okay? But knowing that this is the volume that you want to draw up. Right? Dose in milliliters most of the time, or a better way to put this, dose in volume. Okay. So how does all this work? Well, the best way to do that is to just see it in action. So let's do an example. All right. We have a 12-pound infant who's got a fever going on during an hour-long transport. Now, this is based off of the New Mexico state scope of practice. So make sure that you are referencing whatever your local protocols are to make sure that these medications are in your scope of practice and that you're doing them correctly. That's the proviso here. So this is based off of where I am and where I'm working here in New Mexico. So we need to give this child Tylenol. Okay? Here, you can give this to prevent febrile seizure for a febrile infant during transport. So we decide we are going to give Tylenol. Okay? This is what we have in our ambulance. If you look real closely down here, the packaging gives us the information that we need to do this problem. What we know from this is that the bottle is 120 ml or 4 fluid ounces. That's right here. Okay. And then it gives us a concentration, 160 milligrams per 5 ml. So I did a few things over here. Number one, we wrote down our bottle. Our bottle volume is 120 milliliters. The total mass of Tylenol, of acetaminophen that's in here, is 3,840 milligrams, which if you want the practice, is 3.840 grams. Just for kicks and giggles. But what it gives us on the bottle here is 160 milligrams per 5 ml. And I'll show you that it doesn't matter which one of these you use, you get the same information. So, what is our dose? That's first what we need to decide here. And let's give ourselves a little bit more space. Well, first, we know that this patient is, I'll use blue, 12 pounds. Well, we need this in metric because our dose here in New Mexico is 10 to 15 milligrams per kilogram. Okay, that's what we use as our dose. So what is it actually going to be? Well, we need to convert pounds to grams. So the way that we do this is we simply divide 12 by 2.2, and that gives us a wonderful amount of 5.5 kilograms. Right? So 12 pounds equals 5.5 kilograms. And so to figure out what dose we are going to have, we need to multiply 5.5 kilograms times, and we're just going to pick the low end, 10 milligrams per kilogram, 1 kilogram. Now, I encourage you to write it out like this, because when you do this, you can cancel your units, and you always set the dose pretty much like you say it, milligrams per kilogram, but they need to be opposite, because if they don't, your units don't cancel and you don't get the value that you want. So when we do this, we wind up 5.5 times 10, you move that decimal place over 1, and you get 55 milligrams. If you got something different with this, that means you didn't set up your math problem correctly. For example, if you had flipped this around, make a little bit more room here, do this in red. So this is wrong. If you had done 5.5 kilograms, but you wrote your dose wrong, maybe you said you put kilograms over milligrams, you would have wound up with 0.55. Okay. What this would have done for you is, and this makes sense when you write out the units this way, because none of the units cancel, right? You get 0.55 kilograms squared over milligrams. Okay, that's nonsense. This just isn't correct. So do that. The other thing you might not have done, if you get a weird number that you're expecting, is make sure that you converted your pounds to kilograms correctly. So all these numbers need to be correct in order for you to get the medication that you want. But we know our dose is going to be 55 milligrams. So our dose, which is right over here, is 55 milligrams for this patient. Okay. All right. So how much are you going to draw up now? How much do you draw up? Let's give ourselves some more space here. This is where we use our formula, which is want over have times volume. Well, want is our dose. So how much do we want? We want 55 milligrams. What do we have? We have, and this now is where that amount, the concentration of the drug comes in. So the first one that we're going to do is the total mass that's in the bottle. Okay, we're doing the hard way first, which is 3840 milligrams. Okay, these need to be the same units. Okay. Need to be the same units. If they don't, the math doesn't work. You get a number that is incorrect. Then what is our volume? Well, that is how much is in the bottle. Now, because this number is the total that's in the bottle, we need to use the total volume of the bottle, which in this case is 120 milliliters. So then we set up our equation super easy. Okay. Want over have times volume. So it's 55 milligrams over 3840 milligrams times 120 milliliters. We know this is the correct way because we wind up with a unit in milliliters, which is we're wanting to drop a volume. So our milligrams cancel. We are left with mLs. And when you do this, you divide 55 by 3840, and you multiply that by 120, you wind up with 1.72, and I rounded into 2 decimal places, 1.72 milliliters. This is how much you're going to draw up. Now, just to show you that this works no matter which one of these we choose, right? If we come back up here and we look and we remember that down here it gives us 160 milligrams per 5 ml. The way that I got to the 3840 is I simply was like, okay, well, how many sets of 5 ml do you have in 120? 120 divided by 5, multiply that by 160, and that got me 3840. Okay, that's the hard way. If you just took this and you were like, okay, well, let's go back down here. Our want stays the same. Let's just stay on track here. Okay. Our want stays the same. We still want 55 milligrams. If I'm using this concentration that's up here, okay, 160 milligrams in 5 ml, let's say I have 160 milligrams in a volume of 5 ml. Ourselves a little bit more space. And if we have this, we can set up our equation the same way. Our want is still 55 milligrams Our have is now 160 milligrams. Our volume is 5 milliliters. Okay? When we multiply this through, we get the exact same thing. Because in terms of a ratio, 5 milliliters in 160 mLs is the same ratio as 120 milliliters containing 3840 milligrams. Okay. So this same ratio. What matters the most in this is the ratio between these numbers. And because they're the same, the math works out to be the same. So that's how you do it. Right? Let's look at a super easy example here. Okay, I'm going to say that I have a heroin OD, heroin overdose, and I have decided that I want to give a dose of 0.4 milligrams of Narcan through an IM route. But the vial that I have says it's 2 milligrams in 2 mLs. This is often how you see intranasal Narcan formulated, just for kicks and giggles. But for the sake of this example, this is how your IM vial is labeled out. Well, there's two ways that you can approach this. They're both going to be the same. The way that we're going to do it, just to make life even easier, is realize that this is a 1-to-1 ratio. So it's actually 1 milligram in 1 ml. All right, so what do I want? I want 0.4 milligrams. I have 1 milligram in a volume of 1 ml. Great. I can set up my equation. So I want 0.4 milligrams. Don't forget your units. I want 0.4 milligrams. I have 1 milligram in 1 ml. Now, math, when you're using math and you have ones involved, it's great because it's just times itself. But to make sure that we do this right, we cancel out our units. Okay, 0.4 times 1, well, we already know what that is. That's 0.4 milliliters. This is why I mentioned it at the beginning. When you have a 1-to-1 ratio, the numerically milliliters and milligrams will be the same thing, even though they don't mean the same thing. In this case, when you have a 1-to-1 ratio, you know that 0.4 milligrams is also contained in 0.4 mLs. Now let's say, just for the sake of argument, that our vial, okay, what if our vial was 2 milligrams in 1 ml? How would you do this? Pause the video for a second and make sure that you get the same answer that I do. Work through it, and we'll see. All right, so let's work through this. What do we want? Well, our want is going to stay the same, right? Our dose for the patient stays the same, 0.4 milligrams. We have, let's actually do this correctly. You have 2 milligrams in 1 ml. You have 2 milligrams, okay, in a volume of 1 ml. Not quite as easy as the other one, but still pretty simple. So I want 0.4 milligrams. Okay, I have 2 milligrams. Keep doing that. Milligrams in 1 ml. Okay. Well, in this case, our volume is still going to make our life really easy. Our units cancel. 0.4 divided by 2. You multiply that by 1, and you get 0.2 mLs. Okay. Ratio changed between these two numbers, so our total volume changed, but the concentration, the mass of the drug remains the same. We're still getting 0.4 milligrams of Narcan here in this volume of medication. Right. So what this is saying is that this 0.2 mLs gives us, so it contains 0.4 milligrams of Narcan in that concentration. Hopefully this made sense to you. If it doesn't, leave a question in the comments and I'll happily answer it for you. And good luck in your EMT class.